A few major things have distinguished humanity from all other species, but arguably the most important of these is the ability to transfer information intergenerationally, or to expand on the learning of others to progressively advance society. An important part of this transfer of information is the ability to use written language to store and distribute information. Ink plays a key role in this, as it was independently invented by various cultures across the world, utilizing a variety of sources for its creation. A popular ink used was Iron Gall Ink, which was created by a reaction between ferrous cations and tannins, which are a type of molecule that can be found in a variety of organic substances, and in especially high concentration in oak galls, a small solid ball that forms on many oak trees across Europe and America. When mixed, solutions of these substances change from being relatively clear to becoming a deep black, which works well as ink. In order to better understand the Iron Gall Ink reaction, an understanding of its reaction type, redox, is required. Redox, or reduction-oxidation reactions, are chemical reactions which are categorized by the actual or formal transfer of electrons between reactants. In order for this to occur, one reactant species needs to donate one or more electrons and the other needs to receive them. To identify that this is occurring, oxidation numbers are assigned to each species in the reaction. These are somewhat arbitrary numbers which represent the species' affinity to electrons. If the oxidation number of a species changes in the reaction, then it must have gained or lost electrons to change its electron affinity. In a redox reaction, the species that loses electrons or increases oxidation number is said to have been oxidized. The species that gains electrons or decreases oxidation number is said to have been reduced. You cannot have a reduction reaction without an oxidation reaction, or vice versa, due to the universal law of the conservation of charge, which says that charge cannot be created or destroyed, only transferred. The electrons required for oxidation have to come from somewhere, and thus another species has to be reduced in order to donate the required number of electrons. There are a few rules when assigning oxidation numbers to reaction species. All lone elements are assigned an oxidation number of 0. Monatomic ions' oxidation numbers are their charge. Oxygen in a compound has an oxidation number of -2, except for in peroxides. Hydrogen in a compound is +1, except for in metal hydrides, and the sum of oxidation numbers in a molecule must equal the overall charge. Redox reactions are occurring all over the world around us, in combination, decomposition, combustion, single replacement, and disproportionation reactions. They are in batteries, fire, photosynthesis, corrosion, and even the way we respirate. In our Iron Gall Ink reaction, two smaller reactions occur, one after the other, both of which are redox reactions. However, the second is much more important than the first, as it is where the color change occurs. First, the tannin present, be that within gallic or tannic acid, reacts with the ferrous cations to form ferrous gallate. Note, at this stage the ferrous cations still have a +2 charge, and the liquid is still reasonably clear. Then, the ferrous gallate oxidizes, reacting with oxygen to form ferric pyrogallate and water. This is where the color change occurs, as ferric pyrogallate has a dark black color. It is a redox reaction, as each of the Fe2+ cations donate an electron to an oxygen atom. Thus, the ferrous cations are oxidized, and the oxygen is reduced. If oxidation numbers are assigned to these species before and after the reaction, it can be seen that the oxidation numbers change, indicating a redox reaction. This reaction can be done easily at home using the following method. Two reactants have to be prepared for the Iron Gall Ink reaction. Firstly, a solution containing iron 2+ ions has to be created. To create this solution, steel wool is added to a beaker full of vinegar. Over 24 hours, the vinegar oxidizes the steel wool, observed as rust, where the acidic vinegar takes electrons from the iron, ionizing it to speed up oxidation. This in itself is a redox reaction, as the oxidation numbers of reaction species change. The rust is then dissolved into a solution. If the steel wool is left to rust for a longer period of time, then the solution will be much stronger. However, the reaction does not require a very strong solution containing ions. This solution looks quite cloudy. The second solution contains tannic or gallic acid. This can be prepared in a number of different ways, as there are various sources of these species. The best source would be the same as that used throughout history, oak galls. However, these can only be found in some areas of the world. An alternative to this would be the bark of the oak tree itself. However, this is a much weaker source. At home, the easiest source is black tea, which, though much weaker than the galls, has a reasonable concentration of tannins. The tea is then left to infuse in water. To get a stronger concentration, any of these solutions can be boiled down to a smaller volume. When the two reactants are mixed together, they instantly react to create a much darker solution. A few variables were compared in the search to find the best way of making ink at home. The first was the effect of tea concentration on the darkness of the ink. It was found that as the tea became more concentrated, the resulting ink solution became darker. There is probably a limit to this trend, however it could not be found as a rich enough source of tannic or gallic acid could not be sourced. The darkest ink obtained experimentally was when the tea solution was boiled down to a tenth of its original volume. This yielded an extremely high concentration. The second variable explored was the effect of iron-iron concentration on the darkness of the resultant ink. It was found that the darkness of the ink did increase with iron concentration. However, once more than 20 drops were added, the solution did not get darker. At this point, the ferrous cations are in excess. The final variable compared was comparing different sources for tannic or gallic acid. Bark was collected from various trees. It was then powdered and left to soak in water. The reaction only occurred with one of these bark solutions, the one obtained from an oak tree. Though the reaction did occur successfully, it did not yield a very dark ink. Traditionally, gum arabic would be added to the ink solution to thicken it. However, this was difficult to source at home, and corn flour was tried instead. This was not very successful. When the various inks created in this experiment were compared, it was found that the best ink was created when a high concentration of tannins was created by boiling down a tea solution, then combined with 30 drops of the iron solution. A very successful ink. Literature results support that a 10-to-1 ratio of tannins to ferrous cations is the most successful, as after that, surplus ferrous cations degrade the paper. This supports the findings of our Iron Gall Ink experiment. This reaction can also be used to stain wood, as painting ferrous cations onto a tannin-rich wood will cause the very same reaction, darkening the wood. Iron Gall Ink was discovered sometime around 700 AD, at the beginning of a period of scientific discovery and enlightenment. It was probably even used to write about some of the foundational scientific discoveries that form the basis of the chemistry that we are learning about and discovering today.